Hi boys and girls, here we are again, streaming the second part of the ES6 class, decorators. So for those who didn't join last time, we basically implemented a prototype for ES6 class decorators that work without transpilation. So that was like the whole idea there, that we can make this happen with meta programming. So the idea was that we wanted to run a file, write a node. We don't want to have a build step. We wanted to maybe just like avoid transpilation if we don't have to. There were like some complications, and it's just a build step that we wanted to avoid, and we wanted to just play around with it and see if it's possible. So we implemented this. So I'm going to switch to my screen now. So you should be seeing my screen. And hi, Nuffly, how are you doing? Hope everyone's good. By the way, anyone joining, if anything is not okay, music too loud, anything like that, just let me know. Other thing, if you are in the chat, if you're watching right now and this time is not ideal, I did make a kind of a poll on Twitter to figure out what would be the best time to stream during weekdays. So right now it's always like 6 p.m. on Wednesdays. It seems like more people, like that was Eastern time, more people want in between 8 and 10 p.m. So most likely I will switch to that, but I didn't have so many votes, so it's probably not that representative. So if you have a better time that you would like, just post it in the chat room. Eastern time, just put it there. Aside from that, we'll get started now. So I'm going to push out. You see my screen? Okay, good. So here's the deco that we implemented. Deco name came from decorators, Decoration in German. So the idea is that we can take a class like this, and we can then decorate it, and then we can, thank you Nuffly, I'll take that into account, try to count the votes here. So we can decorate it like this, and the idea then is that, for instance, this onClick handler here gets bound because we have this other onClick thing with $2. That's kind of the convention that tells it that it wants it to be bound. What we'll do today, so this works as this. So this kind of executing this works because onClick was bound. So what we'll do today, we'll first actually test the implementation that we currently have, and then we'll actually change the UI a little bit, the API. I realized that if we pass this here, we can actually figure out, well, we will go in 3 steps. Maybe I'll show you that be in the next episode, but basically we'll do some tests, and then we'll try to do some benchmarks actually. So we're going to use NanoBench for that. NanoBench is a tool written by Matthias Boos, and basically it allows us to say we want to run some function multiple times, and then it tells us how it performed, and then we will do the same thing with another one. So what we'll do, we'll compare using our decorator bind with manually binding, and to want to make sure that we don't introduce any huge performance overhead, right? Also, what we'll do, we'll most likely use DevTools a little bit. We'll load our tests into DevTools and kind of like just run them and see how, where the most time is spent. So we'll do a bunch of that testing, performance benchmarks, and then the idea is at some point, probably I want to simplify this API a little bit, because right now we have to first say deco this class, right? But the thing is, and then we have to again decorate it with this. But the thing is, what we could do, we can just only have this one, and then it will find the class from this, which is possible via the constructor, and then it basically caches So it does it only the first time that we are decorating this class, and then it caches that step. More about that later. For now, we'll just focus on the tests, right? So as we realized last time, in our implementation, which we hacked together pretty fast, we basically are not even looking yet if something is bound or not. Thanks for following me, whoever did. Someone following me? Arno, thanks for following me. I haven't figured out yet how to see this on my screen or elsewhere, so I had to just switch over real quick and see who followed me. Arno, thank you very much for following. Hope you enjoy this episode. So, what did I say? Okay, so basically right now, we are basically binding no matter what. So whenever there's a decorator, no matter what the decorator is, right now we're binding. We're not looking at if it's a bind decorator or maybe it's another decorator, right? And maybe I should, so I really quickly will do a short intro to decorators for the ones that did miss the first episode. The decorators is basically something that you put on top of another of a function, and then something will happen to that function. So that function then, instead of getting kind of stored on the class as is and then executed as is, it will be most likely wrapped in something. So for instance, you could do something before the function is executed, or you could do something after, or in this case, we will bind the function. We can do a bunch of stuff there. You can also debounce a function, there are decorators for that. So that's kind of what we're trying to implement. And they're already available if you use transpilation today. So Babel has a transpiler plugin that allows you to use decorators today, but we're trying to do it without transpilation. So I hope that was clear. Okay, so what we'll do, we just actually leave this as is, and we'll first write a test that actually makes sure that things work the way they should. So let's look at our example that we have here, because we're going to use that as for our test. So here we have a world class. We're decorating it, and then we made sure that we can do on-click, right? So we'll use that as a argument. I'm going to make my terminal a little smaller. If it becomes too small, let me know, because if it's too small, it's too big. I don't have much screen real estate, so there's not much space to open, for instance, two files next to each other. So I hope this is still fine. If not, let me know. So I'm going to start writing a test here. Okay, so actually we're going to name this bind, because it's going to use bind in this case. And actually what we're also going to do is we're actually going to remove that placeholder test. Actually, remove it. All right, so now we should only have this one. So just importing tape. So tape is a test runner that I like to use. It's very simple. It's basically based on assert. It has output to the console that's called tap. So basically tap means that's human readable. And thank you for following me, Jessity. I hope I said that right. And again, I have to keep switching back to see who followed me. But thanks for following me, everyone. So tape is a test runner that spits out tap output. So actually, let me show that real quick. And it's authored by Substack. So here we have a simple example. Basically, we just run a test. We can plan. We can also call end. And the output here, this is kind of readable by humans, right? But also very parsable. That's kind of the benefit of tap, that we can read as humans. But also, if you write like, if you're like on some continuous integration module like Jenkins, you can then basically make sure that you can then parse the output of tap or tape, and then you can kind of like automate like your dashboard, right, where it tells you some tests failed, or you can notify someone, right? So that's the idea of tap, and it's very simple, so I like it. So what we're going to do is we're going to paste our class in here, but the thing is, like, let me switch this over here. So now the test is over to the right. The thing what we want to do, we want to have two methods, right? One that we bind, and then the one that we don't bind, to make sure that actually this only works for methods that we do want to bind, right, with this decorator. So we'll call we call this bind, right? And then we have another one function, just another click handler that's basically doing the exact same thing as that one, except it should fail if it's not called on the class, right? Because we will not bind it to the class. Hope that makes sense. So only this one will bind. So now basically, right? So this is the bind, and that should work, and the other one should fail, right? So basically, I'm just going to make this really clear. These are our fixtures, right? That we're going to use to test, and then the actual tests will actually start below. So let's see. We could create this in our test also. Okay, so basically now we have a class that is decorator. So let's say given a class whose on-clicked bind, or like, let's just say with bind decorated function. So let's just say we have that, right? And let me actually put my phone over here. So what now we can do is we can say, okay, if we call, we're going to actually create the other one too, right? On-clicked, right? So one should be bound and the other one should not be bound. So if we call on-clicked bind, or let's just call it bound. So what I'm going to do is I'm going to do a search replace, and I'm going to do bound. I'm going to make sure that it respects the uppercase casing, so it only replaces the uppercase bind bound. So on-click bound, right? So if you call that, everything should be fine. So in this case, we can actually already start running a test. So we need to import deco. Just copy that from over here. And actually deco would be just this, right? So let's see, cannot find module tape. Okay, so let's go and install that. So what I'm doing here with the uppercase D, I'm just saying I want this as a def dependency, right? Because if you want to use deco, you don't need tape. You only want to when you're actually developing on the module. So that's what the uppercase D. So basically what happened, it got added to my package.json here automatically, right? With the right version and everything. And actually I'm going to change that to a caret because this is a def dependency and I trust Substack to follow somewhere. Okay, so now, can't-read property of undefined. Okay, interesting. So, oh, because we, well, oh, see, mistake here, right? By the way, if you see me making mistakes, please call me out in the chat. I'm trying to watch it all times on the right here, because we're doing this together, right? It's not just me. I hope you also learn something from it, but it's kind of like a group effort, right? So, let's see. So basically what we can put here, we can put a pass, and we can say that calling the bound method does not error, right? Because otherwise here we wouldn't have gotten here if we would have errored, right? And now we can have another one. If you call onClicked, right, then it should error because well, actually, we're not. The test should say we should say it this way: the method decorated with bind is bound, right? Let's just say that because that's actually what we're proving, right? Doesn't matter how, but that's how we prove it. So now we're going to say t.should or t.throws. Right, and we're going to use ES6 syntax, so we're going to use a lambda function here. We're going to call, actually we don't have to, we can just say onClicked, right? Because what that will do is it will call onClicked, and there you go. And then it should crash, right? And then the test will pass because the test expects it to throw. So method not decorated with bind is not bound, right? That's the whole idea, what we want to test here. So see, okay, so we got 2 passing tests. Let's see if there's a does not throw. Okay, so that's even cooler. So we can do this, does not throw, right? And then we just pass on click bound in here, right? Does that make sense? Basically, in both methods we do the same thing, right? And only if this is actually set to the world class, then let's put test here to make it that. Then it will actually work, right? And otherwise it will throw because it will say there is no basically this is not defined, or there was no method hello on the this, whichever this I got, right? Okay, so now we got some tests here. It's pretty awesome. So that's a good start. So now we can go and we can first of all change it a little bit, because now so one thing that we do want to say is right now we don't have any decorators, any other decorators but click. But once we do have them, we want to basically make sure that if we have a decorator that's not bind, then we also don't want that. So actually, it's an interesting one. So actually, let's introduce another decorator just for now. So let's call that, what can we call that one? So we just call that we may be going a little too far here, because we will have other decorators, and I believe in the future they will just be functions, and we will see why. So let's now look at our actual implementation again. So as I said, we kind of were looking at, we were binding everything, right? So what we actually have to say is we have to wrap all this stuff here into a function where this is a binder, right? So this is actually a decorator, which we will pull out into a different module, right? So we'll not do that yet. Function add bind decorator. Okay, so I'll just call it bind decorator. Okay, so in this one we'll get we'll get the descriptor, and it needs to target and the descriptor, and it will in the future we will support options. For now we won't. Okay, so now we basically pulled out that functionality, and now we can say so where did this come from? I confused myself a little bit. Decorate here, right? So basically what do you have? We also need the function name. We do need the function name. So name, right? So let's save that. It doesn't. Oh, so right now we have a let's call this new descriptor, and do it here. And the cool thing is that now we can kind of hack here around, and we're protected by our tests. So if you break something, we would know pretty much right away. So so now we're going to say bind decorator, and we're going to pass the target, the function name, and the descriptor. Yes, and that's x dot descriptor, right? And it's also x dot target. Well, the target is passed to us, so that's interesting. We already have that. So we have that twice. So now let's see if our test still passes. Okay, cool. So we didn't destroy anything, right? So now what we will do is we will actually look if we really wanted to bind, right? So we need to say we need to find a way to figure out which decorator to apply, right? So here's the decorators, right? So what we'll do, for now we will have a const. We'll have some decorators, like some known decorators, and that's going to be a new map where we are going to map bind to our bind decorator function, right? So those are some known, and we will have to see if our API will support adding known decorators, or if we just say you just pass a function. We actually want to play around with both of these APIs in a second. So so basically now what we'll do is we'll have a nested loop, or let's say we make another function here. Function apply decorators. And so we will have the decorators, we will have the target, the function name, and the descriptor, right? So what we'll do, put that here actually, and in a second we'll use it again. So now what we'll do here, apply decorators, and we pass the x.decorators. We will pass the target, we'll pass the function name. Where's the function name? Here we go. And we pass the descriptor, right? And so now here we say for name. For now it's going to be name. Let's call it x to make it easy to type. So for x of decorator, so decorators is at this point an array, right? So we'll try to resolve the decorator. So we'll say known decorators if dot has x. For now we're going to throw an error. And we're going to use template strings decorator, so we can just put inline that x so later on we may say please configure it or something like that, right? So now we are kind of across lines, so right. And otherwise what we'll do is we'll say known decorators dot get x, and then we'll call that with a thing. So what we also should do is right, so actually what we'll do is we'll use the assert module here. And by the way, the thing that I just did, this is like a Vim macro that I defined myself, so I can quickly add dependencies. So again, all my stuff, if you're interested, is in my .files. So if you are kind of like, wow, what kind of settings is this person using? Not decorators, sorry, .files. They're all here. So that's a Vim stuff of my other settings. So if you're interested, you can check that out. Actually, I'm going to paste it in the chat here, so you can just click on it. All right, so now, so we got assert. So instead of doing this nasty error thing, we're just going to say assert known decorators that has x, and otherwise and then here we say first of all we get the right? The decorator function is basically needs to be a function. We need to assure that too. Otherwise, we crash in mysterious ways. So we're going to say assert fn. We say dot equal type of fn function. We'll say decorator was not a function. All right. Okay, cool. So that's not much nicer. And so now, if everything is good, though, we can call it. Okay. So and then here, all we have to say apply. We would do that. So now it's okay. Canary property of. Okay. So now we broke something. Good thing we have the test. So let's see what happens here. Try decorators. Target if enemy pass everything more in. So let's look at the error message. It's inside the bind decorator, and the descriptor is null or undefined. So somehow we didn't pass in the descriptor correctly. Decorators target event name descriptor. Let's think about this. By the way, if anyone sees the error of who's watching, let me know. So we'll just log the descriptor here to see if it's already not defined, and I think it's probably already not defined here. So actually it is still defined here. Okay, so that's interesting. So we're making mistakes somewhere here. Fn target, Fn x. Oh, see, that's the problem. We do x.descriptor. Okay. All right. So as you can see, very important to have those tests, right? Because otherwise, we already would have had a problem. So now we actually are only applying bind. So let's just say that's the implementation we're going to go with for now. We could obviously add some more tests, but actually I want to get to the benchmarking part. And excuse me for 1 second as I will open the window. It's a little bit hot here. All right, thanks for waiting. It was getting a little bit hot. I'm streaming this from Medellin, Colombia. It can get pretty hot, but if you open the window and the nice air comes in, all good. So now we will start working on the benchmarks. So what we will do, we will actually create this world class thing. We'll just take that, and we will actually instantiate it multiple times. So one problem, before we do that, one problem with benchmarks is sometimes that they are not really representative of how things will really be used. So what could happen is if we are actually creating this benchmark and we are like doing something like in a tight loop or something, right? What could happen is that then the JavaScript interpreter V8 starts generating really optimized code for that case, just because we're doing it so often and in such a short time. So we have to be a little careful that our benchmark is actually not kind of contrived, so to speak, right? Because a benchmark is useless if the scenario that it's using to demonstrate the performance, if that's never the reality, right? So we have to be a little bit careful there, but we'll just start implementing it, and we actually, as I said, we load it into Chrome DevTools to kind of see what's going on, and yeah, let's just do that. So I'm going to make a directory, and we're going to make a benchmark for bind. So here we have our world class, and we need deco. So here we have that. So now what we're actually going to do, we're actually going to first run this without even NanoBench. I just want to load this actually into Chrome DevTools and kind of just have a look. So what we'll do is, so we create a iteration variable, and we're going to start with let's start with 1,000,000 iterations. And so what we'll do is we will basically just create a new class and throw it away. But the problem is that if we do that and we don't call anything on it, then V8 will just probably be smart enough and say, okay, well, you're not doing anything with that thing. I won't even like do anything in that loop at all. Even though it needs to think that maybe in that constructor we have a side effect. So we'll just call some function that does basically nothing in here. So do something. I would just call it side effect, right? Because that's kind of what it's supposed to do. Side effect. And what we'll do, we'll make it increase side effect. So we're really trying to prevent Chrome, sorry, V8 from just compiling our code away because it may realize that it's not doing anything, right? So that's kind of first thing in benchmark you have to be careful with. So what we're doing, we're going to say our world class, new world class. And so first we're just looking at instantiations. We might do another one where we're actually going to look at calling that bound function. I mean, that shouldn't perform any different because it's the same, right? So basically what we do, we also have a bind function here that will manually bind on clicked bound. So, and what we actually do here is we will pass in a flag auto bind, and that's going to be false by default. And so, if we auto bind, we do this one, else we call our bind. So that's the difference. And then basically is on click bound is this dot on click bound dot bind this, right? And then also we actually are going to have create a function. We have to say, okay, auto binding or something. And so we're really not worried about this actually at all, because this will take almost no time. And it only will happen once. So when we were looking at performance, we were more worried about the actual process of applying the decorators. Pulling out the decorators will only happen once, right? When we actually call this line here, and that only happens when we initialize a module. So auto binding. So we're going to say our world class. Actually, you know what? Let's not make sure we don't create any. The problem is that if we create an object to pass, that might incur performance overhead. So here we say we want to auto bind, and that's basically what we do. And then we call world class dot side effect. Okay, so and then we'll just call that. Ding. Okay. All right. So what else? Side effects is 0. Side effects. So we're not using side effects anywhere. Okay. So let's make everything happen. Also, like make sure that that it actually has to do this. So this was 1,000,000 times. Okay, that's good. So now we want to actually profile that, and we could use node inspect to do that, or we can just say let's just boodle our file, and then we say --- open. So boodle, what's boodle? Let me show you Boodle is a really cool, quick and dirty way to pull something up in the browser. So this code that we wrote, right, tape, all this stuff, all went in the browser, right? In this case, we're not even using tape for the benchmark. So we can basically just say boodle index.js open, and it will automatically generate like some page for us that then will load our file and run it. So that's what we'll do. Boom. Okay, so, and it will host it now. So now what we'll do performance profiling. So we go to the performance tab in Chrome DevTools, and we will just say we want to record, but we want to record when it's loading. I wonder if I can do that. So actually what we'll do is we'll wait for a little bit, set timeout, auto binding, and we'll say give me a second to press the performance button, right? And then we'll log side effects before, and so we need to log it now in here, right? Makes sense? Because otherwise it would set the timeout, it would log 0, and then it would do that, but this works. So now we say, okay, load yourself, wait a second, so we can start the profile and then start doing the loop, right? So let's reload, and then, okay, so we have to obviously rerun it. So we'll just run it in a different tab, Udo, and run the benchmarks bind. And so now if we refresh this, now we can start recording. So it's profiling, and it already printed 1 million. That was quick. Not really seeing much. Yeah, that's not really, that's nothing. We didn't really succeed. Let's try, let's actually put the console on the bottom so we can see. We may have to do a few more than 1 million. Oh, this is really, whoever works on DevTools, because it makes this easier to grab this. Oh, there you go, finally. Okay, and we don't need to see this stuff. All right, so all we want to see is when it prints out the result. So what we'll do, we will say, let's do this a little more, and we will, so now we're doing this 1 billion times, and let's give it like 5 seconds. Okay, so now we should be good. So refresh, 1, 2, 3. Okay, I guess we can start. So now we're profiling. It didn't print anything on the bottom yet, so it's still running. So let's see, obviously it takes now 1,000 times longer, so we might just want to stop it after like a few seconds. Okay, so here we go. Seems like that was a little bit too much. Let's actually go back to this, and yeah, I probably want to kill this now. That was a little bit too much even for Chrome. Yeah, I can't even close. Okay, so now let's try this again. So what we'll do, okay, now I printed. So we'll go back to performance, refresh, 1, 2, 3, 4, and now we start profiling. And then in a little bit it should, and profiling also makes your things run a little slower, right? Because profiling actually takes a little time. Okay, so here we kind of see what's happening. Obviously, it's all inside the auto binding function. We can zoom in on some of this stuff though. All right, so we don't need this stuff. So I used to be able to, yeah, okay. So now we're gonna zoom in. Okay, so that's gonna just show us that, I just want to see the call tree. Okay, so let's look at some of the, so I just want to zoom in on like a little bit. I think the UI changed somewhat. That's why I'm a little bit trying to come to grips. So here we can now zoom in to what's going on here. So apply decorators is taking some time, and then bind decorator, calling that function, takes some time. So basically the applying, right, almost takes the same amount as the actually binding. So what my my initial idea would be that it's actually the binding that takes that long itself. So we might not introduce any other overhead here. So what's that anonymous thing? Let's see. Can we go there? Okay, so that seems to be either inside of Chrome or something like that. So okay, so what we'll do, just as another test, we'll copy this and we do a manual binding test, just to see how that behaves. Manual binding. So, and then all we do here, we pass false, and now it should do the same thing, except now it should never call a decorator code, except when it initializes and pulls the decorators, right? So it's complaining that we're not using that method, not a big deal. Okay, so what we'll do now is we'll actually refresh it again and record another profile, and we'll keep the old one as a comparison. So let's refresh 1, 2, 3, roughly 4. Okay, just did it in time, seems like. So okay, seems like we really didn't see much there. Okay, here we go. Manual binding. Okay, so manual binding also took some time. Where did it time? So inside bind, right? So what we'll have to figure out though, interestingly enough, here it was much faster. It didn't even see it, it seems like. So this is interesting. So let's actually let's do another one. 1, 2. Let's just start now. Okay. And let's see. So it looks like we may be introducing performance overhead, but we'll test this and close with nano bench in a second. So why that be? That is really interesting. So it seems like that is interesting. So it seems that we might be introducing some considerable overhead with our way. So let's look why that would be. Let's look at our coding in here. So, well, we are looping through the decorator rules, so we're doing all that extra work. And then we're looking it up in the map, obviously. And then we're applying it. So what we could do though is obviously we could cache. So basically what we could do is, if you give us the same instance, the same function, right? This we will get the same decorator. So we'll have to see what we can do here. But let's now switch and do the actual nano bench. So we have a little more data. So nano bench is very simple. We just require it like this, and then we give it our functions. And we already have the function, so we're almost ready. So let's do that. All right, cool. And we're gonna say bench, and we're actually gonna make it auto binding times, and then we do our auto binding, and then we say manual binding, and we say manual. So I said we're already pretty much ready for this. So obviously now we need to install this. So there's a little nice shortcut I added to my Vim. I think it's called, no, that wasn't it. Okay, so that installed it automatically. There was a shortcut that I added. Again, look at my .NET files if you're interested. So now that, well, actually it should have added to the dev dependencies, so let's fix that. Okay, cool. So now we should be able to run it. Bench was never ended. Okay, so yeah, it's not that easy, right? So let's go back to the docs. So we have to say b.start and b.end. Okay, that's fine. Not a big deal. Let's say b.start and and we do the end before we print something, right? So apparently, where does the b come from? I think it's passed to us. Yeah. So b.start and b.end. All right, so that's cool. And so, whoa. Okay, so we are adding a bunch of overhead. So basically, let's analyze this in a little more detail. So let's do a benchmark, and then over here we're kind of trying to calculate. So we're doing it 1,000,000 times, right? So we're taking 1.8 seconds for 1,000,000 times. So that's like 1,800 millis. No, 1.8. Well, it gives us here in 1.8. What's 1.8 second? I guess that's 80% of 60 is 48. So it's basically 1,000. It's like sorry, what am I thinking? Seconds are whatever. Yeah, I'm not thinking straight. So it's basically 1,800 milliseconds. And if that's wrong, please post it in the chat. But that's I'm pretty sure of that. So basically, we're adding 1,800 milliseconds, and we're doing it 1,000,000 times, right? So we're adding 0.0.018 millisecond per iteration. So if you're creating, I mean, this is like 2 seconds, right, for 1,000,000. I mean, depending on what you're doing, this could be a problem. So see if you can improve on that. So let's actually look at what gets called when. So when we call deco initially, we pass the class, right? We create a new deco from the class. So the init function, that's only called once. But everything else here is called multiple times. So, but we already know that the actual overhead was bind decorator, right? I mean, remember that from the DevTools. Did I close it? Yes, I closed it. So the overhead was inside of bind decorator, right? So we could now go and try to optimize other things, but the overhead was just there. So let me actually let me actually just copy this code out. Let's not run the bench, and we'll just run this directly, right? So that should work. Interesting, since we required bench, it still gave us some output when the process exited. I guess that's how it works. Let's just not require bench then. So now what we'll do is we'll wrap another function. It's called profile, and we'll pass the auto bind in if we want it or not. So basically what we'll do here, we call that like this. And now what we'll do is we'll just again set a timeout of like a few seconds. And we actually use ES6 here now because we want to pass in our variable. Well, so true. And let's say we give it 5 seconds again, right? So now let's go back to over here. And let's call it with Budo. And actually, let's say we want to open it. All right, so now let's do DevTools. Get the performance tab ready. Refresh 1, 2, 3, 4, 5 roughly. Let's examine again where our problem is. What is going on? Maybe we're not printing anything to the console anymore? Is that what it is? Oh yeah. So we want that because otherwise we don't know what we've done. Okay, so, but actually we are fine. We just zoom in on this. So this is a profile function, right? And so it has multiple of these decorates. So let's look where the time actually is spent. So it's spent inside of decorate, right? And then I'll have to figure out like what's decorate actually. So there's find decorables, so that's still some time. So we can here look at find decorables took a total time of 0.13 milliseconds, at least in this case. I thought there was like a summary where you could see aggregated time. It doesn't sound right. Okay. So bind decorators is actually what's taking like, so right off. What's funny is like it's run multiple times instead of one decorate. Why would that be? I mean, am I seeing this wrong? So here we have one decorate that took 0.4 milliseconds, and about, let's just say 13%, well, 0.4, about like half of that, or no, not half of that, but okay. So actually, like the bind decorator is not taking all the time. What I don't understand is like why decorate took so long here. What is this? That doesn't make any sense. 2. So that's kind of baffling, right? So what was it doing here? So it's one decorate call that's calling apply decorators multiple times. Find decorate all the stuff multiple times. Why is that? Let's actually go back to our tests. We'll use our tests to figure that out. So we should at least only see one. So if we run this, right, we should see 1 times decorate, right? Because we're only calling, right? We're calling this class 1 time. We're creating this class 1 time. So why are we? Sorry, yes, we are seeing that, but like we should only see apply decorators like 1 time, right? Let's see what's going on. Decorate. So we have one decoratable, right? So let's log here. Applying, and let's say applying the decorators. So now if we see this multiple times, then we have a problem. We're only seeing it once, like we should. That makes sense, right? The question is like, why do we see it so many times in here? It may be that this is actually confused. But I mean, this should be like a call seg, right? So we call profile, and then we call create the world class, and then decorator is called, and then it should only do this once. Okay. So okay, let's just assume that this output is flawed in DevTools. Let's just assume that for now, because I didn't really think. And let's actually switch the music for a second, because this is not really such a cool song. Sorry, whoever made this. But so we have. I mean, how in the hell are we applying multiple times? That doesn't make sense. I think somehow this is confused. Maybe it's like so close together that it doesn't see it as two calls or something like that. But basically, regardless, so let's look at one. It's still a bind decorator SIG most of the time. So even if we were to apply like if you optimize this, we have some gain, but not much. And I have no idea, honestly, why this is taking so long. We have a okay, so that's interesting. We have a garbage collection happening, but that doesn't happen so often, so that doesn't really affect us too much. So get on docker, find decorator roles, get on property descriptors. So let's look at that. Find the, okay, here. It goes here. So basically what we could do, we could first of all, we could kind of start caching we could memorize some of this. So if you give it the same prototype and the same name, we then would just not call this again. We would just basically reuse the previous value. Prototype shouldn't take that long, but I mean, it looks like that's taking a little bit of time here. Again, like we are basically just trying to optimize the parts that we already know are probably not the culprits, but maybe we can improve that. So let's just write down the numbers that we got before. So for 1 million, we got 1.8 seconds, right? So let's see if we can improve on that. So what we'll do is we'll look up some memorize function. Let me see how my stream is doing. Okay, good. Still streaming good. The internet here can be sometimes tricky, so I want to make sure that it's actually streaming well. Okay, now let's look at memorize function. So let's try to find the best. So there are multiple memorizers. Wow, okay. I know that I've seen, so this only has really few downloads. This one looks a lot better. There's a lot more downloads. So let's look at the. Okay, so this looks from the stars and everything looks good. So what can you actually memorize? Can you memorize on functions? So it seems to be the best memorizer in the world, or the fastest one. So that's interesting. So we'll just trust that. And the fact that it has so many downloads and so many stars, we'll just for now leave that as enough indication that this is a good one. The question is, so we memorize a function. Now the question is, does it cache support objects? Because we were going to pass in a target. Oh, we need a serializer. No, hold on, that's not what we're looking for. Doesn't explain. Well, we'll just try it. We can also look a little bit at the source code. Maybe we can understand it quick enough. Seems to be. So is primitive okay? If it's not a primitive, what does it do? Otherwise, it serializes the arc. Okay, interesting. So what's the default serializer? Serializer default. Let's see if that serializer is smart enough. JSON stringify. Oh no. So what we may have to do is we may have to memorize the function. Because basically what we're going to pass in is a prototype, right? But hold on, we could create. We could have one per proto that we see, right? So, say we're getting a target, and the proto is the object. So let's go back to DevTools and play with this a little bit. So if we have like, let's take a sig window, the proto. So var or proto equals object of prototype of the window. Okay. So what's that? So that's the window, right? So now we can actually get the constructor name. Right? And for the function name. So what we could do, we could create this is actually a little tricky. And I feel like we're kind of optimizing in the wrong part anyways for some reason. Okay, let's just call a function. Get descriptor. We give it a proto and we give it a function name, right? So what we could do is we could say this is getting hacky, really hacky, because basically what we need to do, we need to. What about the serializer? So how does the serializer work? Let's see if we can do something with that. Okay, so actually what we'll do is this. So we'll, okay, fine. So we'll memorize this function. So right, we have to install the memorizer, npm install -s, and I think it's called fast memorize, right? Yep. So fast memorize. Cool. Now we'll import that. Okay, so, and then basically we say we memorize this function. And basically all that does is this, right? Okay, and so that's that, and we're going to pass in some options. So what am I doing? We're going to pass in the serializer. And the serializer is going to be a function that takes the proto. It will only call us for the proto, right? Because the fn name is a primitive. So we say proto dot constructor name. So if we call it with the same constructor, it should match it. And so now what we'll do, we'll replace this with get descriptor. Everyone is happy? Yes. Okay. So now let's go back to our benchmark and let's actually run it. We're only going to do the outer binding. We're only worried about. So we'll comment that part out. We might need it later again. Okay. So 1.8 seconds, right? So pretty much the same. Actually, it got worse. So, let's see how often we get called in here. What we're going to do, so we don't go crazy, we're just going to do process standard. This is another nice little trick. If you want to write without putting a new line, you can do this. So now let's see how often we get called. We only got called once. So we actually only got called once. So the memoizing part works. I would think that's an improvement. Except, you know what we're going to do? We're going to actually make sure that let's call this, we're going to do this Java S, and we call this impl, right? And then we say get descriptor impl. So now what we can do is we can say we can just comment that out, and we can say const get descriptor equals get descriptor impl. Right? So now it's basically going to call a method without memorization. So memorization makes everything slower. Interesting. So interesting. So okay, memorization not working. So what we'll do is just what I'm guessing is that if we don't use memorization, the get descriptor function is inline by v8. And if we actually wrap it in this, then it's not inline. So basically before we had, yeah, so now we're back to 1.8 roughly. Not good. So we couldn't improve on that. Let's see what else. So we apply decorators, find decoratables. I mean, that's what we saw, right? That was the overhead that we saw. Let's see what else we can find here. Various rotations like the rings of Saturn being sucked into the dimensional vortex of a black hole. Look, maybe we can actually, yeah, we can't memorize the bind decorator because that is basically what that does is basically a side effect, right? So we can't do it. But maybe we can improve something here. So we're creating an object. So the thing is, why are we creating a new one? Maybe we just want to do it this way. So we'll play around with this. So we remove now the fact that we're creating a new object. That got us down a lot. Okay, so that's good. Now let's do something else. Instead of doing all this stuff, we just say descriptor value equals, and we just do that. So right, which should work. Use the descriptor, and then basically here we pass in descriptor. Now, okay, so let's do it now. Okay, wow. Okay, so now we are half as slow. We're improving. So now we are half as slow. Now the other thing we could do, maybe if we do this, we don't have to do this part anymore. Look at that. So now we're super fast. Problem is, our test is still passing. Nope. So basically now our test broke because actually need to do this. Okay, good. So now our tests are passing again. Okay, so let's see. So we are down to 881.4 million. Still a lot slower than the other. So let's turn actually on. Let's turn on the manual binding one, so we have a comparison again. So we have 16 milliseconds versus 890. We're still a lot slower. Let's see. So we're still like 50 times slower. I mistyped. So that's 50 times slower. It's not good. So okay, but we can maybe do better. So maybe we can, instead of doing this with a descriptor, we can do it directly on the target, right? So maybe we can say target of fn name equals. So this is like this super shortcut. Value the bind target, right? I mean, we can't do it any shorter than this. So let's put this outside. So also making the function small, so we know it can be inline. Did that improve something? Not really, right? So actually, let's run. Let's make the iterator a little larger so we get more consistent results. Takes a little longer to run, about 10 times as long, but we get better. So we got 4.62 seconds assigning directly to the target. Okay, so around 4.5, 4.6 seconds, right? Is it? Okay, so now let's undo our changes here. Let's do it the correct way. Let's see if we get any better or worse or whatever. Hold on, how did that? Whoa, we got a lot worse if we do it that way actually. As you can see. Yeah, it's clearly worse. So this is what we had before. So what? Okay, we'll try one more. So let's do this one again to confirm. Right, so it is a lot faster this way. It's not exactly how I wanted to do it, but so what if we actually get the what if we actually don't ever get the descriptor? So let's try this. So if we do this, right? And then we bind this way. So we never access the descriptor now. So we had 4.5. Let's actually put that down somewhere. So we got to 1E7 4.5, or let's just say 6 roughly. So now we actually got worse. Okay, so that now we actually got worse, as you can see. Right? That is definitely interesting. So, but one thing I wanted to try is, what if we don't even ever get the descriptor? Right? So what if we just say, we never pass that? Because like, if we do it this way, we don't actually need the descriptor, right? Because we are just working on the target. So we could have decorators that have the option to say, I don't need the descriptor. So maybe here we just, so let's just see if that works with the crash. No, it works. So that got us faster, right? So not needing the descriptors is, okay, so 3.28. So that's kind of, so basically using descriptors, we get that, and 3.28 is not using descriptor. Okay. So that is interesting, right? So basically what we want to do here is we want to pass a boolean basically put this line here, right? So only when we include that. Let's actually put that on a sort of nice little line. Okay. Right? Okay, so where is that being called? It's called here. And so basically we want to pass some ops here. No, actually, who knows that that's funny. We don't know until we actually resolve the decorator, right? If we need the descriptor or not. So we actually need to postpone getting the descriptor until here. So this is interesting. Actually, we only need the proto for this also. So this is basically right. So let's put that here for now. And no fear, we will fix this all. And we make sure the test that still works. So now basically the decorator itself will tell us if it wants a descriptor. And how does it tell us? The descriptor is the last one. Right, that would be one way. But actually what we'll do, we'll make a class for this. Can I do this? No, I can't. So, and then we say, so this is all not really cool. I'm just going to make this an object. Because I don't want to slow things down unnecessarily with using a class and like a getter and all this stuff. And then the right, so the decorate function will be the decorate. So whichever. So this will all be obviously in a separate module eventually, right? Okay, so that's that. And so now we'll have the bind decorator in here. And what we'll do is we get the proto, and then every time we find decorator, then we ask it if it wants the descriptor. So, and then we just take the descriptor here. What do we call it? Needs descriptor. Descriptor. Right, so only then will we actually pass the descriptor. So actually our search might also cost some time. So for now, he'll remove everything. Well, actually, we cannot remove two things and then make a insertion, right? If we change multiple things and then do another benchmark, we don't know which one of the changes actually fix things, right? So the function is now basically decorator dot decorate. Okay. Did I overwrite some? No. Okay. Let me actually make this the only window. Okay. So that's the function. And the decorator needs the descriptor, then we pass the descriptor, otherwise we call it like this. Right? And basically what we'll do, we will resolve the descriptor at the very last moment possible. Right? That makes sense. That looks okay to me. So the function we need always, so we can also already pull it out here and check it here. Okay. So what is it complaining about? Put an equal sign here. Okay, and now it should be all. Why is it still complaining? Descriptor. So yeah, we don't have that anymore, right? So if it doesn't want a descriptor, we just pass this. So in this case, this guy will not have a descriptor. And that's it. And so now it's very, very fast, hopefully. So now benchmark. 3.5 seconds, what did we say before? Not using the scripter, so we're basically still back, we're still like, we added a bit more probably because we do all these checks now. Right? So we got let's just say 5 using the scriptor via option, right? So now basically we have that option. It's not looking too bad. I mean, we got it from 8.5 or something. We got it down to 3.5, which is good. So let's see what else we can apply. So basically, like what we're looking at right from this path, because this is what's happening all the time. So here we're just structuring. We're creating an array. but we're only doing that once because there are only one. So that's the thing, find decoratables. Why is that? What's happening every time? So maybe decoratables we can. So we don't need include descriptors, makes sense here anymore. Could we maybe memorize this function? Right? It's a target. The map. Where does the map come from? The map okay, the map. Okay, so the decorator's map is coming from here, right? Think about this. So finally we get the target. So we should actually memorize finding those by the target. Well, actually we can. So what are we actually doing? Oh, look at that. So basically the only reason why we need the target we don't even need that, right? We don't necessarily need that step. We can actually, all it does is set the target and the decorators. And we're not even using the target here. So we can basically just delete this whole thing. So this is because we hacked this together fairly quickly, right? So let's just comment this out for now. And we're gonna say that
Are these feelings even real?
we already have this. So now basically what we'll do is we have the fn name. We'll just go through them. So let's think about this. So the decorators here. So those are the actual decorators of the function, right? Let's think about this again. So we order decoratables by function name, but we already have that. All that we're converting is these decorators into a thing that has decorators and the target. We don't even need that. So if we just say the same thing basically, x of decorators. So the decorator well, and so I'm confused about why I'm a little confused. So apply decorators, you have to actually look at that that's happening. Okay, here basically that's what I'm talking about. So we're just using the x of decorators. So basically we don't need this. We just do this dot decoratables. This dot decorators. Right? Let's see if our test will pass. Decorator is not iterable. Okay. What is let's look at what that returns. So basically it's just It's just the decorators, I believe. Those would be the decorators. And now I'm confused. Let's look here. What we get? We get the key. And the d dot value, which is basically okay. And then here all we were doing, we were iterating over them. And we're just adding like that. All we did basically is include the target. That's pretty much all we did. So we don't need that. So what's up with the scriptor? So we don't use the scriptor. That was the confusing part. So I think it would be this. This is a decorator, and then this is not there anymore because we get the scriptor on demand now. Okay, now it's testing. Okay, cool. We're good. Now let's see. That improved anything. Okay, look at that. Now we're down to 2.1. So we are basically slowly but surely getting an okay kind of performance. Alright, cool. So what else can we do? So we get decorate, we go through this, right? So what we'll do is I will remove these. So let's run this a few more times. 2.18 is pretty constant. Okay, so about like a little more than 2 seconds. So now what we'll do, we'll remove these asserts. Maybe what we can do, we can do it some other way of doing this. We can find maybe another way of checking this beforehand or something. So let's see what that does. Okay, that does. So asserting takes some time. Okay, so let's remove the asserts for now. This is very performance too much. So basically, so what was it? 1 point, I don't want to lie, I can't remember. It was, let's just say 1.8 roughly. Okay, so the other thing, so okay, so we don't use it has anymore, just getting it. So let's do that. Let's remove this one, and let's basically delay this if we. So we only get the proto if we actually need it. So see what we're doing here? We're basically saying that, okay, if the proto is still null, then we're actually getting the proto. Because here we don't, sorry, we do this actually here. Because only here we actually need the proto. Here we don't need it, right? So in this case now what we'll do is we're getting the proto on demand, only if we need it. So that should speed us up a little more. And then basically the first time after we got it, now it's set, and then we'll just keep reusing it. So let's remove the assert. All right, cool. Now let's run this. 1.43. Okay, is that faster? Yep. So that's faster. 1.4 roughly. Moving or getting proto on demand. So that is kind of cool. So now what I'll do, so we'll check this in for now, and what we'll do is I want to benchmark this against, there's an autobind module that Syndrasaurus has. I want to kind of compare that to that. Obviously, I knew it was going to be slower than kind of just manually binding, right? I knew that was going to be the case. So basically, the idea is that we want it to still be not too slow. So the alternative, basically, you can manually bind, right? By just writing code like that we saw earlier. You can use our module, or you could use Syndra's autobind. And now I kind of want to see how that compares to our module, right? If that module is a lot faster, and if it is, well, I mean, obviously, then you could still argue the functions that get autobound that you don't need to be bound. They could be slow when you execute them. But I wanted to see even just a step of initializing a class instance, if that is a lot slower in our case. So first of all, let's clean up a little bit. And what we'll do, we will check in the test and everything that we changed. We're not using the memorize function at this point anymore, so we'll remove that again. So let's actually remove that like this. And let's look at our package.json. We got nanobench in there, that's what we need. Okay, good. So, and let's run the test just to be sure. Okay. So what we'll do, so what was our last document? Okay. So mainly I made sure we applied correct decorator, improved performance by simplifying code and getting scripture only when needed. Okay, so we can push that up. So now what we do, we'll add another thing to the benchmark. So what we'll do, we'll look at, yes, we're doing decorators. Oh, why? Hi, Lumi. So the reason why we want to do that is, so right now you can do decorators via. So basically, decorators right now are not part of JavaScript, right? They're not part of even the accepted spec, I think. So right now, you can't use decorators unless you transpile. Like for instance, if you use TypeScript, you can turn on decorators, right? But TypeScript transpiles to JavaScript. Or you could, use Babel for your code, and then you just transpile also to Java. So you're using like a JavaScript with extra features and transpile to JavaScript that actually exists. I like to work, if I'm using Node, I like to work with JavaScript that actually does exist at the moment. So I don't want to have, when I kind of like want to run my code and see if it works, right? I do that a lot directly from the editor. I want to just do that. I don't want to have to worry about now transpiling this. I don't want to have to worry about maybe including in Babel runtime in my code. I don't even think that would be enough for decorators, because you actually need to rewrite the code, because putting an add there with something that will just throw an error, because at this point the JavaScript interpreter will not understand what that is. So I want to avoid that step. I just want to be able to run my files directly, but also I want to get some of the benefits. And last but not least, I just wanted to, kind of see how that would work, play around with it, and kind of look at what kind of meta programming features we actually have in JavaScript. So I hope that answers your question. If you have more, just let me know. So we'll continue. We're just about to look at the auto bind. I hope this is going to be it. Otherwise, we're going to have to find it. This is not the one. So let's look for auto bind Cinder. Hopefully Google is fine. So this is the one that is really, really popular. Well, relatively. And that basically just goes ahead and binds everything. So we are not parsing JavaScript. So what we're doing, I'm going to show you. So parsing, the parsing, so what we're doing, reflection is done basically on living things, right? So basically, we are not in control of parsing. So the V8 is parsing. So yeah, we could, I guess, do some parsing, but what we're actually doing, I'm going to show you real quick. We're using functions like to get descriptors. So basically here we see where we're actually getting the. So first we get the own property descriptor of the class, and then from those we look for all of them that have they are prefixed with the with the $, right? And so if you find one, then we say, okay, this one will actually give us the decorators for the function that's actually here, right? So that for the same function with the same name, except it doesn't have the $. So that's kind of the convention that we used. And we made this one static, so we can basically find the decorators one time. So basically here we can say one time we find all the decorators on that class type. So we only do that once the module initializes. But then basically we use other forms of reflection later when you actually then decorate on the target. The target then is the instance. That's where we basically apply the decorators. So we go through the decorators and we get the prototype of things if we need them. And here if we need the descriptor, we actually get the own property descriptor. In our case, for the binding, it was actually fairly simple because we just needed to basically say, give me the function and reassign the function, but bind it. We actually didn't need the actual descriptor, but other decorators might need that, so that's why we have now the option. So basically you find that here, find the operator like this, and you tell me if you need the descriptor. If you don't need it, then we can be much faster because then we don't need to fetch the descriptor, because we found actually getting the descriptor, so this function here is actually pretty, has overhead. We tried to memorize it, that didn't work really well. And basically what we did, we used a nanobench to go down in time that we took. So we started actually worse. We started with like 8 seconds or something. And then once we improved some of it, we actually had like 1.8, right? So that's actually 18 seconds. So if you multiply that by 10, right? So that's kind of where we started. So we were really doing really badly. So this is kind of like 10 million iterations, right? So then we went down and down and down. We kept improving things. Let me try to make this bigger so you can see it better. So we kept on improving things until we got a decent performance. So now we're at 1.4. So it's per seconds versus like 18. So that's what we found using nanobench. I hope that answers your question, but the main point is that we're calling methods on either the class or the instance of the class to find which decorators to apply, and then to actually apply them and overriding the original functions. That's basically what we're doing. So, yes, so basically we wanted to, let me actually close this one. We wanted to compare to the autobind. So autobind basically will autobind everything. It takes options. So I guess you can tell it which ones to autobind. Let's see what the options do. Where does it explain the options? Options include. Okay, so you can basically. So this is also not. So Nomi, right now basically we are not focusing on the decorators itself, we are trying to write a way. Yes, it's basically AOP. So we are basically providing a way to add decorators, right? So the idea is that then others could write decorators, right? And basically they just follow the API that we provide, where they basically say, this is my decorator, it does need the descriptor, and this is my function. And then we'll pass in what the decorator needs, and the decorator then goes ahead and does what it needs to do. And it is AOP. You could use it for aspect. So for everyone else who doesn't know AOP, what that means is aspect-oriented programming, which means that we can add kind of like features to the functions that are kind of perpendicular to how the function works. That's kind of a mouthful, but basically what that means is you can wrap a function with another function. So yes, you could do before-after hooks. In this case, we are binding the function, so we're basically modifying the entire function by binding it, so it becomes a bound function. So we are not limited to anything, because as you can see here, if you can, whatever you can do by replacing the entire function is up to grab. You can even, if you need the descriptor, right? If you pass the descriptor, you can even say, I want to change the descriptor and I want to make this function readable. So now I cannot read only. So now I can no longer overwrite it. There's a bunch of stuff you can do. I had this all here. I think maybe that one was a good one. So I'm going to put that here. Maybe the other one was better. So for instance, here you get the descriptor, right? And you can say writable is false, and now I can't overwrite it anymore. Okay, thank you very much for letting me know. I will turn down the music, and I realized also that the music was a lot, probably not that. So yeah, everyone who's watching, please let me know if something is like that is going on. So hopefully now it's better, Lumi. By the way, if you're interested in this, just follow me, and I'll put out more episodes for this. We're running short in time, but there will be much more coming. I at least have one more episode about decorators. So be sure to follow me, and I suppose in 2 weeks I'll be able to continue. Next week we have a company outing, so I won't be able to do that. But basically here you get this descriptor, and you can see that you can overwrite stuff. Okay, it's still a bit loud. Okay, let me actually change that here then. I have this awesome thing. I can set this. Okay, so hopefully this is better. But thanks very much. Thanks for letting me know, because I do not know how you guys hear it. So let me find. There was another post that I found that was good. Is the one that I just opened? Yes. So this is maybe the other one, which explains it in more detail. So yeah, so this explains it really well. So I will just basically paste this in. I'll paste this one in, and also the one by Adi Osmani, because it's also pretty good. And I will just also paste a link to the MDN object. Get on property descriptor. So that's one that you can start looking at. So that's where we can get the property descriptor of, you know, for instance, in this case, it would be the property descriptor of the function. And then we can be, basically what we're doing, we're changing that then. And you can see that it has enumerable, configurable, and all this thing. So let me paste that in here as well. Okay, so this is pretty good. So at this point, we are, okay, so let's go back to where we were. But thanks for all these questions. Want to make sure that everyone actually takes something away from this, learning-wise and so on. And the better everyone understands, the better you guys can help me as well. And goes. So this is auto-bind. So it appears that you can actually give it an option to where it only overrides specific methods, which is kind of cool. We'll use it first to override everything, and then we'll use it and we tell it only override our function, and then we'll compare that to our solution. The thing that I don't like too much about it is then the autobind thing, right, happens somewhere, and then you got the methods. So you kind of have to look upwards, like so. I say like here, right, in our example, you can see right above that this is bound, right? But if it's all up here, you have to kind of, you see this function, you don't know if it's bound, and if the class is kind of, you know, pretty big, you have to actually go up and look at what's bound and what's not. You have class level decorators. Okay, so class level decorators are also intended to be added to JavaScript, but as far as I know, they are also not part of real, of currently spec'd out JavaScript yet. So we are basically based on ES6 for now, and as far as I know, they don't have class level decorators. Lumi, it might be that you're using, I don't know, are you maybe using TypeScript or something? Or if you're doing front-end development, most likely you are transpiling. If you're talking about an old version, I wonder if maybe ES4 had decorators. Because ES4 is basically this idea of the next version of JavaScript that never happened. So let's see if that. So here's a real story behind it. Oh, the old bubble decorators. Okay, so yes, when you're saying old bubble decorators, that still means that they have features that are so new they are not even part of JavaScript yet, right? So yes, there are bubble decorators that are, but basically the idea is that I want to avoid having to transpile, right? The goal of this is to be able to just have code that is just pure ES6, but still gives me kind of decorator-like features. So that's the whole idea behind this. So now, let's go back to our autobind, right? So basically, we're going to benchmark against autobind now too. So all we do now is in here we add autobind. We do autobind all here, and we do the same thing. It doesn't matter that our class is kind of modified a little bit. So what we'll do instead, so let's look how the autobind. It's not that I don't like it. The question is why I don't like code generation transpilation. It's because, look, for instance, right now, I'm in a test right now, right? Right now I can just press Ctrl R, Command R, and it runs. I can just play around with code and it just runs immediately in Node, right? I don't need to wait for a build step. I don't need to hook up Babel. So I do actually use Babel, or I use maybe sometimes Buble, which is an alternative to Babel. So let me pull that up. Let's see if it'll find it. Nope, that's not what I wanted. Goes in the Bible. That's interesting. So Buble is an alternative to, let me see that's the right thing. Yeah, it's basically the alternative to Babel, which I use a lot for frontend. But the thing is, like, I want for Node, I don't like that. For Node, we actually like on a really good version of Node, which, you know, Node 8 supports a lot of ES6. Yes, Lumi, I totally agree with you. I totally agree that it doesn't have to be a problem. It doesn't have to. The thing is that I don't like a build step in Node. So I just Node has a lot of features already that are, for me, are sufficient, and I can just run the JavaScript that it supports. And so I just wanted to see if I can add that one extra feature that I like without having to switch to transpilation. But you're right, it's not a time problem. It's more like a practicality problem. And the other reason, as I said, is we just wanted to see if it's possible, right? Like we just wanted to play around with this and see, do some meta programming and so on, right? So let's me, okay, so now let's get back to where we were. So const auto bind require auto. And I wanted to actually see how it's meant to be used. So auto bind, you just say auto bind this, right? So what we'll actually do, what I would like is a full pull. See, this thing is like, for some things you can't do pull fill. So if I put that in my code, right, or like bind. Now if I try to run, look, already my linter tells me, what is this? I don't know what this is, right? So it can't even parse it, right? So basically what would happen if you were just trying to load that into Chrome or with Node, it will just already not parse a file correctly. So that's why what I'm trying to say is that there's no way that you could just polyfill it, because it's not a function that you call. It's actually like a language syntax feature, and if that syntax doesn't exist in the version of JavaScript you're using, it will just not even parse it. Right? I hope that makes sense. So basically now we create a new class. We don't want our auto binder to happen, and then we'll just basically use the auto bind module like this. Yeah, you're totally right. We could do that. That's a possibility where basically, but now if I'm running the file directly with Node, I can't. I'd have to run it with Node Babel or something, right? Which is an option. So let's use auto bind all. I'm kind of excited to see what that will bring. So we don't need this necessarily anymore. So see how we compare to that. No way. No way. Why is it so slow? Can't believe this. Okay, so that's interesting. It doesn't even finish. Did we make a mistake? So let's change the iterator to a lot less. Let's do it 1,000 times only to make sure I didn't make a mistake. Wow. So we are slower than manual binding, but we're way faster than auto bind. Way faster. So let's do 10,000. No, that's 100,000 actually. 100,000. So we are basically auto binding. Our auto binding takes 31 milliseconds. Manual binding takes about 4 milliseconds. We're still 6 times slower, but the auto bind all takes almost half a second for 100,000. So let's keep it at 1 million, right? And auto bind all takes 5 seconds, and we are taking about 200. Wow. Okay, so that's interesting. So let's see. Well, you could already require. Yes. Of course, that's what Node Babel basically does. And actually, authored a module I'm going to show called Proxyquire that does that for testing, right? So I'm fully aware that you can do that, but the thing is, I don't want to have that in my way, right? Just to add, so this is a thing called Proxyquire, and then basically what it does, you can mock out things. So I'm just going to put that in the notes here. But basically, it allows you to override what require returns. So in your tests, you can kind of mock things out, right? And you're totally right, Lumi. You could totally do that. And the thing is, maybe someone should write an alternative. Maybe you can do that if you want to. Write an alternative that only focus on decorators. That's not as maybe as heavy-handed as Babel, and maybe that integrates better. Here we're just doing another option. So hope that makes sense. But I'm pretty impressed that we are way faster than Orbital. So what we got to do though is, so we got to be fair and we got to pass an option, right? So what you got to do also, we got to say autobind all. We got to say autobind specific. So actually, we call this decorate binding. So we put that here, manual binding. So let's rename our function to be a little clearer here. Manual binding, decorated binding, auto bind all, and then auto binding specific. So specific, what we're going to say, we're going to pass some options, and let's see how that works. So we will pass. So actually what we'll do, we'll actually put that in our constructor so it's all fair. But we'll first look at how options. It's an array of strings. Okay, so we'll just pass exactly the name of what we want to autobind, which is basically onClicked, right? So that's what we'll do. Actually, this is fine. And actually what we'll do here, we'll move this out. We'll move this code, we move this out to be able to better, to clear, like do this in our implementation here. So world class dot bind, let's do that. Here, decorated binding, we have to do this one. And we say world class. So now we don't need these anymore. And now it's much clearer from the benchmarks here what's actually going on, right? All right, so should be that. And so here then we use the same thing, except that we give it the options of what we want to bind. So now we need to change our test. So we start with manual binding. Then we have, so let's make it decorated binding, and then we have auto bind all, and then we have auto bind specific unclicked only, unclicked only. Okay, I'll get you a question in 1 second, Lumi. I just want to see the result of this here, specific. Right, so now we're doing basically specific. Okay, so now the specific should not be so much slower than we are. Okay, let's look at this. So decorated binding, 148 milliseconds. Auto binding all took 1 second. And actually, if you're specific, it actually becomes worse because I suppose it has to scan that every time. So that may not be fair, but that's how the API works. Can't do anything about that. Yes, Lumi, we actually did say that in the beginning, that you have to be very careful with benchmarks, because what happens is if the code runs a lot different than you actually in the real world will run it, you might get misleading results. Totally agree. So yes, running things in a tight loop might actually cause optimizations that normally wouldn't happen. But we definitely see some difference here. So we actually also looked at Chrome DevTools to see what kind of, in the profile, what kind of stuff took a lot of time and so on. So basically, we kind of secured ourselves a little bit. We kind of looked at it from different angles. But you're right, we have to be careful to not put too much meaning in this. But the thing is that the differences here are pretty substantial. So obviously, like manually binding is still like about 8 times faster. But I mean, that's a lot better than where we started from. We started from like 55 times slower or something like that. The interesting thing is that we are beating the autobind module, which is basically the other option right now that doesn't use kind of the decorator-like thing. It uses a different API, but it seems like we somehow are beating it in speed. And well, let's be fair though. Let's allocate this before, right? Because we don't want to allocate that all the time. So let's do that. And actually, let's remove, I don't think we need this. What we'll actually do is, we will remove this hello thing. We just say on click bound, we just say this is how we call it. We remove the side effects function. We kind of clean things up a little bit here. So we just call this hello, we just throw away the result. So we don't need the side effect thing anymore. So what we do instead is we call actually on clicked. And we actually call that, well, you can't really, yeah, we don't want to affect our benchmarks with that too much. We do know it works. So if we just do that, maybe we're fine. We don't want to log this out anymore. Right? So and let's be totally fair, we'll do this exact same code. Right? And actually what we'll also do, we'll just allocate it outside. So that's what we'll do. Allocate it outside, assign it like this, auto bind it. But actually no, we can't do that, right? Because we need a new instance. Well, yeah, it's a new instance every time. So that will work. Because what we can do then, we can then call and make sure that it's actually, we can call the method that should be bound without the class, and we can make sure this actually works. All right. Did I answer a question about installation of the decorator? Installation. Let me see if I see where the question. So yes, so basically the operators are defined for the method on the class level, right? But we are overriding, we're actually applying the decorators to the instance, and that is correct. Because what we want to maybe, well, first of all, you might have instance methods only, so you want to override on the instance. And secondly, what could happen is that you have decorators and they take options. And so you instantiate your class and you give options that then apply to the decorators. Like for instance, what I was thinking of is if you have a callback API, right? But then maybe someone wants to use async await, right? You could have a decorator that tells deco that, hey, this is a function that's asynchronous. You could promisify this if someone wants to, right? It's a function. So basically then this, whoever instantiates the class says, I want the async await version, and then it finds all the methods that have the async decorator and then promisifies them. But then if I don't pass that option, then those decorators just won't be applied. So we could have, but we could extend this to where this becomes a lot more flexible. And that's why I want to apply this to the instance. Also, obviously the bind method, right, would only work on the instance, right? Because we are binding to the instance. We cannot bind to the class because the class will not have the state of it, right? So if we're saying, for instance, this dot configuration, right, that would be on the actual instance, not on the class, right? That's the other reason why we want it that way. So what I'll actually do is I will just say we will have a test function here. Just bind, and we'll basically pass our world class, and we'll just say cons on clicked equals world class on clicked, and then we say we invoke it. And so that way we make sure that nothing fishy is going on. This is actually doing what it's supposed to do. We're not like winning or something because we're just not doing anything. And as you can see, we finish the benchmark before we do that. So we don't affect the outcome of the benchmark with that call. All right, so let's do that also here. So we put the world class outside, right? And then we'll just extend it here. And we'll do it the same way. So actually here we have to do it this way because autobind doesn't work. Does autobind work this way? I do think it changes. Let's look at the code. Does it give us a new, so this is a self, it applies it to the self, right? It returns as a self as well, but yeah, so actually it does change it right here, right? So it actually changes, so we don't need to actually assign the one that's returned. So let's do it this way then. And then we auto bind the world class. We don't need to reassign it, no need for that. So now we actually have everything very, very similar to how it works anywhere. So we don't need the side effect counter anymore. See what else happened. Different from having like my decorator clause of promise. Yeah, exactly. So that's the idea, right? That you have the decorator, and the decorator gets applied however you want to, right? And it only gets applied to the functions where it makes sense. So that's the other thing. If you cannot say, give me my class with a promise, because how would it know which functions to decorate, right? Which functions should it wrap and promise with promisify? It has to know that at least that function is async, or maybe another one is not. So that's the reason why you would have to use a decorator there. But let's see how this works now. Can we probably... Haha, look, our test didn't work. That's interesting. So manual binding, it failed after manual binding. Okay, well, because we need to bind it, right? We removed that from the, hold on, are we binding? We are. That's the weirdest thing. So now I'm really baffled. So Lumi, if you see anything, let me know. So let's just first of all rule out that is the other benchmarks. Okay. This sort of low didn't work. On click. Oh, bound. So we need to actually remove this one because, well, actually let's leave this in to confuse bind all a little bit because bind all performs worse the more methods we have, obviously. So actually, you know what, we're not going to be that mean. We're just going to say, nope. There's only going to be one method. Well, there's also hello, so sorry. But we want to confuse it the least possible. But obviously, bind all will perform even worse the more methods there are in your class because it will bind them all, no matter if you need them or not. Okay, so now that works again. Okay. A good thing we put that in a function so we could change it in one place. Okay, so as we could see, auto bind all is still like about 4 or 5 times slower. I'm not sure what you mean, Nomi. Like, so they could be all implemented on the prototype. Only the reason why I'm using a static method is because then I can do something once on initialization. I'm going to show you. So basically here, right, I'm doing this one time. So basically what we're doing here, we're kind of gathering all the decorators that are there. So basically all the static methods are called, and then I have a map where I store all the decorators. So then each time you instantiate that class, I don't have to look them up again. That's the reason why I have the static here. If I wouldn't have that here, then basically every time we create a new class, I have to do the whole process. I have to, again, find all the methods that have double dollars and then store that in a map or apply that right away. But in this case, what we'll basically do is like the first time the only one time when you create the class, I find all the decorators that you need and figure out which function names are that I need to apply them to. So basically on click bound. And then when you actually instantiate the class, I just go through that map and then boom, I do it. What does bind do? Well, bind basically, so when you call something in JavaScript, right, and you don't put this in front of it, right? If I say world class dot hello, right? That means that now this that's passed to hello will be world class because it's right before the dot, right? Now if I want to assign that hello, like this, now I call hello. Now that this is actually not longer world class. It doesn't work like in other object-oriented languages. So this one is totally different than this one. But what I can do is I can say hello.bind world class, which basically means that I'm overriding that behavior. I'm saying every time you call this function out, automatically I want this to be the world class. So that's basically what bind means. I'm connecting this basically to the functions. I'm binding them together, kind of. So right now we are kind of in a good place. So we got an interesting benchmark. So actually what I want to do, I want to make this a little clearer here that we're dealing with the auto bind module. Because what we're going to do, we're going to put this into our README. Oh, actually here, this is interesting. Why does this even work? Because we told us specifically on click, right? That is a weird thing. See what happens now. Still faster. So let's just be very clear what we're doing. Yeah, exactly. So doing Lumi, I think you're confusing something there. I can't. The bind works on the instance, right? So each time you create a new world class, you need to bind it to that instance of the world class. So, or let's say if I have countries, right? I could have a class country, but what would I bind? I could bind country, but now if I say I'm creating Japan and the name is Japan, what will this .name return if I bound the function get the name to just a country, right? So basically you have to bind it to the actual instance. So maybe I can find a good thing for you there. So you can also, because I think you may not fully understand how different JavaScript this works from like in Java or something. So it's a lot different. So what you could read up is on the prototype, because you also keep mentioning a prototype. Basically, classes are using prototype under the hood. So see if that would help. So for instance, here we have an example, right? So it says this.name, right? So when we call this greet on the person, it will say this.name. Well, the name is different for each person, right? So this actually has to be the instance of that. Like it has to be the person with that name. Let's say Bob, right? So that means that we can only bind it to an actual instance. We cannot, if we bind it to the prototype, that doesn't help much, because then the name will just not be what we want it to be, right? We want the name of that instance, right? So that's kind of how that works. So I'm actually going to paste a link there for you in the chat, because I think you might be a little bit confused. Oh, okay. Oh, of course, that's manual binding. We're actually doing that. Look, I have a bind function here. Look at that. That's exactly what you're talking about. So yes, you can do that. The pain point is that now I have to remember that every time I create a new function, I can't see from here that up there is bound. Like imagine a class is bigger. So it's actually arguably like, more convenient to just say this, and then I know it's bound. And I put it right above it, and it looks like kind of like a decorator. It's kind of the same thing as saying, bind, just in a little more verbose way. Right? So that's the whole idea that we're trying to do. Okay, so what we'll do is we'll copy this. Actually, what we're going to do, we're going to call it a deco binding. Okay. Interesting. Well, we had it in constructor before, and I do believe that it's possible. Well, actually, let's try it. So let me just I'm just going to paste this in a README, and we'll try that. But I did that before, and we got it. I mean, this is like still like way fast. Look at that. It's like 24 milliseconds compared to ours. It's way faster. So let's do benchmark here. Comparing manually binding to binding with deco. Let's say versus binding with deco versus binding with, let me put a link there in a second. And then we'll get to that in a second. Let me. So Let's copy autobind in there. Okay, so now to your question. You should not. No, I agree, Lumi. I totally agree with you. The thing is, this is a benchmark, right? So we have to do it multiple times to see how this will work. So what I'll do now is I had a constructor here actually before, and what we'll do, we'll just only run the manual bind test, right? And as we could see before, we had about 24. We had 21 milliseconds, 24 milliseconds, right? So about, let's just say slightly above 20 milliseconds, right? So now what we'll do is, instead of manually binding here, like you say, that's not nice, we'll just do it there. So then we basically, and in order to make it even better, we'll just even avoid this call, right? So we'll delete this, boom. And now we run it. Let's see. So we got 23 milliseconds, 24. And now we got 18, 26, 18, 23. So it's actually comparable, right? So we got like 20 or 22 or something around before. I do believe, I agree with you. But see what we're doing here, right? We want to, what we want to do, we want to, in our benchmarks, we want to be really clear about what we're doing. So you can see in the benchmarks that that's what we're doing. We're binding with this, here we're binding with deco, here we're binding with autobind. If we don't want to do anything hidden here in the class. Exactly, transparency is most important. And if you're just building this class by itself, I totally agree that you should bind in the constructor. Totally agree with you. Here, actually, in order to have that transparency for the benchmark, we want to be actually very transparent about what we're doing differently in each case, right? So kind of same argument, except that it's a different use case, right? So at this point, actually, we will be finishing, running way over time here. But we have a really interesting result. We'll put the benchmarks up and push that up, and then we should be done. So I will sign off for now. Let me actually, before I do that, let me put the link in the show notes, or whatever you call it in Twitch, the chat. So anyone interested in this? So again, next week most likely you won't be able to do a show or a stream, but in 2 weeks we'll continue. So I want to thank everyone for watching, and Lumi, thank you for all these questions. It was definitely an interesting discussion. And yeah, go ahead and make that work. I don't have time right now to wait for that to happen, but you can either file an issue. As I said, definitely follow me, and you can also send me messages, I think, on Twitch. You can also follow me on Twitter and send me messages there. So I'm going to put up my Twitter here. That's my Twitter, TH Lawrence, that would be me. TH Lawrence. So let me actually put that also here. So if you want to follow me, and Lumi, if you whip something up, I would really like to see it. So tweet at me, and maybe we can have a look also in the next episode. Okay. So again, thanks everyone for watching, and I'll be signing off now. Bye bye.